All right, guys, so we're going to do these problem 7, A, B, C, and D. I'll explain them as best I can, and then we're going to do problem number 13 here using these functions, okay? So the first thing I want to talk about is we have a function here. The function name is called W, okay? And here's the actual function, the equation. We're going to use this equation to fill in this table here, okay? So how does function notation work? And this is kind of the whole section this week was just function notation. All right. So the way function notation works is we have to name our equation now. In this case, our equation is named W. So if I say, hey guys, look at equation W or look at function W, you would look at this equation. If I said look at equation or function B, you would look at function B, which is this equation. Okay? If I said A, you would look at function A, which is this equation. All right? So again, this is just how we're going to name our function. The thing in parentheses is our input. So right now, if you look in parentheses for function W, we are inputting the letter A. Okay? So whatever goes in parentheses next to the name or the letter of your function is the thing you are plugging in. Okay, so we're plugging in A. That's why we see A here. What we're going to do here to complete the table is we're going to change our input from A into a number. So in essence, all we're doing is taking these numbers and plugging them into our A value, our input value. Okay, and we're going to do that. And I'm going to fill in this table for you, and then we're going to talk about domain and range after. All right? So let's do this. We're going to take our first input. So as a reminder, this table, the top is our inputs. This bottom part is our outputs. Okay? Our inputs are the A values. So our A values can be 1, 2, 3, 4, and even another letter, H, or another variable. Our outputs are the answers to our function when we plug in something. So it's the answer to our equation W. That's what's going to go here. Okay? As a reminder, our inputs are also called our domain, and our outputs are also called our range. Okay? In IM1, this was called the X. This was called the Y. All right? It essentially means the same thing. The only thing we're doing now is writing our answers a little differently. Okay? So, what we're going to do is, let's go ahead and I want to find the output when my input is 0. So I'm going to take this equation and I'm going to plug in 0. So let's do that here. So I have W, and the input is going to be 0. And anywhere I see A, I'm plugging in 0. So it looks like this. 0 cubed minus 0 squared. Okay? And now all we have to do is, we're just going to do the math here using order of operations, PEMDAS. So the first thing we want to do in this case is exponents. 0 to the third power is 0. 0 to the second power is 0. 0 minus 0 is 0. So the way we would write this is equation W, when we input 0, our output is 0. So again, when we input 0 to equation W, we get an output of 0. So we're going to put 0 as our output. All right, and we're done with that one. We got to do the next input. So all I'm going to do now is, instead of plugging in our input of 0, we're going to do an input of 1. So I am plugging in 1. So again, how does this read right here? Using the function W, I am inputting 1. That's all this means right here. We don't have to even do math here. It's just, this is a new way of plugging stuff in. Using function W, I'm plugging in 1. So I'm going to plug in 1 wherever I see A. And then we do the math. 1 to the third is 1. 1 to the second is 1. And the reason for 1 is it's 1 times 1 times 1. And this one is 1 times 1. So 1 minus 1 again is 0. So function W, when I input 1, gives me an output of 0. So I'm going to put that output here. So as you can see, guys, we're doing what you've probably done before in Im2. We are just plugging stuff in, okay? It just looks different because we're dealing with what is called function notation. And this is something that's a big deal in Im3. That's all we use is function notation. Okay, so we got to learn it in Im2. All right, the next input we're going to plug in is 2. So I'm going to plug in input 2. So input 2, equation W has an input of 2. So let's plug in 2. All right, so just be careful here. This is not 2 times 3. This is really 2 times 2 times 2. Okay, and this gives us 8. This here is 2 times 2. And this gives us 4. So 8 minus 4, that gives me 4. So with equation W or function W, when I plug in 2, my output is 4. Okay? So keep that in mind. That's all we're saying. Input, output, input, output. So input is 2, output is 4. Let's do the next one. Hopefully you're getting the hang of this. It's not too bad. The next input we're going to plug in is 3. Okay, so again, this is 3 times 3 times 3. This is 3 times 3. Let's do that math. This is 27 minus 9. Okay, 27 minus 9 gives me 18. And that means using my function W, if my input is 3, then my output is 18. So that's where I'm going to go here. All right, and then one more, actually 2 more. One more number and then 1 letter. So the next input is 4. So we're inputting 4 into equation W, function W, and we get 4 times 4 times 4. Please don't put 12, but it's 4 times 4 times 4. Here is 4 times 4. This gives me 64. This gives me 16. And if you do the math correctly, you should get 48. So function W, when I input 4, my output is 48. Okay, and the one thing I want to point out in this table is, and it's showing it here, is we don't have to always just plug in numbers. What makes functions special is you can plug in other variables into our function. So my input here now is going to be H, a letter. So we treat it exactly the same. So my input is now going to be H. Let's see what that looks like. Okay, so we're going to input H. So I'm plugging in H, which sounds kind of weird, but this is just what we're doing. We treat H exactly like we treat the numbers, and then we do as much math as possible. H to the third power is just H to the third power. H to the second power is just H to the second power. And then we check, can I clean any of this up? And the answer is no. These are not like terms. So this is actually my final answer. So that means in my function w, when I have an input of h, my output is this equation. So actually I have an output that's actually another equation. Okay, now I wanted to point that out to you because you'll see later on we're going to be able to plug in all kinds of things into our functions, not just numbers. All right, especially when you get to Im3, you plug in graphs, you plug in all kinds of stuff. Okay, so hopefully you get it. It's basically we're just doing input output over and over and over again. The only thing that's different is the way we write it. Okay, so function w has an input and then we put our input there. Okay, we don't have to do any math for this side of the equation. This is just letting us know we're using a function and letting us know what our input is. Okay, now saying that, we want to talk about domain and range. But if you look at the hint in my equation or my problem B, it says we want the domain based on the equation. All right, we don't want the domain based on the table. And let me explain the difference. If we were doing the domain based on the table, remember your domain is just your inputs. What are we inputting into our function? All we would have to do is list these numbers here and h. So we would have a number list of 1, 2, 3, 4, 5, 6 things. Okay, but what we want to do here is we want to look at the equation and ask ourselves, can I plug in anything into my input? So right now we only plugged in positive numbers, 0 through 4. What we're trying to figure out is, are there any restrictions to what I can plug into the A? Can I plug in negative numbers? Can I plug in fractions? Can I plug in decimals? Okay? And the answer to that is, if you plug a fraction in and do the math correctly, will your calculator give you an error sign or will it actually give you an answer? Okay? And 95% of our functions, we can plug in any type of number. Okay? Because of that, our domain is not just these numbers, but we can plug in any number. There is no restrictions on what we can plug in. This is called all real numbers. Okay? So that's the terminology for the domain when you can plug in any number you want. But I want you to get used to writing it using math language. Okay? And what I mean by that is another way to write all real numbers using symbols of math is by using what is called interval notation, which looks like a ordered pair of numbers or a point. Okay? And we're going to fill this in with two numbers. The first number that goes on the left is, I want you to think of it this way. What's the smallest number possible that we actually can plug in for A? I just told you we can plug in any number. So that means we can plug in the smallest number in the world. So the smallest number in the world in math, we call that, we can plug in any number all the way to negative infinity. Okay? The other side says, what's the biggest number you can plug into A? Well, since we can plug in any number, the biggest number we can plug in to A is positive infinity. So this means we can plug in any number from the smallest number, negative infinity, to any number to the biggest number, positive infinity. So we can plug in any number in between. Fractions, decimals, big numbers, small numbers, negative numbers, positive numbers. Okay? So this is just another way of saying all real numbers. We're going to start using this, especially in Im3. We use this a lot for domain. Okay, this notation. This is called set notation. The other notation you have to be familiar with is called interval notation. It looks very similar to these symbols. It starts off like this. We put down the smallest number we can plug in, and then we put down the biggest number we can plug in with the space in between. Okay? And what we want to put in the middle is, what is the variable that we use to plug in? So if you look at our variable, what's our input variable? It is A. So we're going to put A right in the middle. Okay? And this says we can plug in A to any number as long as A is bigger than the smallest number. So A has to be bigger. A is bigger than the smallest number. So we could plug in any number bigger than negative infinity. And vice versa. We can plug in any number for A as long as it's smaller than the biggest number, which is positive infinity. So that's why we put these inequality signs or alligator mouths. This says we can plug in any number bigger than negative infinity, and we can plug in any number smaller than positive infinity. This guy and this guy mean exactly the same thing. Okay? All right. Guys, I'm not expecting you to be like, oh, I get it. Mr. Fernandez is the greatest teacher ever. He make a lot of sense. I'm not expecting that. This takes practice. It took me a long time to understand this, okay? It's just we're going to have to keep practicing this language. All right. Range. Now, range is basically our output, but the same idea. We don't want to just list the numbers anymore. We want to look at the equation. Is there any answer we can't get? Any output we can't get? If we can plug in any number, doesn't it make sense that we can get any number for our output? Okay? So again, if we can plug in any number, it makes a lot of sense that we can get any output number. All right? Which means our output is all real numbers as well. Okay, so what does that look? We use the same notation. Since it's all real numbers, our range is negative infinity to positive infinity. We can have outputs that range from the smallest number in the world to the biggest number in the world. Same thing happens in here. Interval notation, we use the same language, okay? But instead of using A was our input, but our output has this name. Our output is W of A. But we write it exactly the same. Okay? So like I said, I don't expect you to understand this right off the bat. If you do, great. But we're going to have practice with this because it's not always the negative positive infinity. Majority of the time it is, but it's not always. Okay? So we got to get used to this, and we'll do some practice with that. Let's jump over to example C. It says, suppose function W, when you plug in an A value, has an output of 18. So remember, this is now our output. This was our input. It's always about input, output. So it's saying using function W, we want to know what was our input if our output is 18. That's how you read this. So let's look at the table. We really don't have to do math here because we already did it. So we're looking for function W's output when it's 18. So we go to the output table and we look for 18. So we see 18 here. What number did we input to get 18? And if you look, it's number 3. So that means our A value is 3. So our input was 3. It's that simple. Okay? If we jump over to D, we kind of have a different thing. We are given, remember what's in parentheses like that, that's our input. And we're trying to figure out our output. So basically, the way you read this, it says, find our output if our input was 4 when we use function W. So now we're looking for the input of 4. What's our output? 48. So that means our output, which we will put here, is 48. Okay, so it's once it gets explained, you start understanding this. This stuff is really easy. You just have to understand after the equal signs your output, the guy in parentheses is the number you're inputting. Here's my input. What's my output? Okay. Let's jump to number 13. In number 13, you have three different functions. You have function A or equation A, you got equation B, and you got equation or function C. What 13 is asking you to do is it's asking you to add two different equations together. Okay? And if you understand the input-output concept, we're going to do that now. So let's look at this guy, C parentheses 4. We have to get used to this language. This basically says, look at function C, which is this guy, this equation, and I want you to input 4, and then tell me what your output is. So if you input 4, what would be my output here? So it's basically saying this, take C, and instead of X, we want to plug in 4, and we want to do this math, which we want to figure out what our output is if we plug in 4. So our output, if we do this math correctly, the square root of 4 is a simple answer. What multiplied to itself gives you 4? And that answer is 2. Okay? So we have that. Now it says, all right, you figured out the output for C. Now I want you to figure out the output for A. So we look at equation A, and the input we're putting in is the number 3. So we're going to plug in the number 3 into equation A. So it's going to be 5 parentheses 3 squared minus 2. Okay? And what we're going to do is, once we get this output, we're going to add the two outputs together. So let's clean this up. Order of operations says 3 squared is 9 first. So this turns into 9. 5 times 9 is 45. Bring down the negative 2. And 45 minus 2 is 43. Okay. And we are adding 43 and the other output together. And 2 plus 43 is 45.
45.
You got it. So that means this equation is equal to 45. So as you can see, with function notation, we actually can add equations together. That's essentially what we just did. We added two equations together. And that's what makes function so special. Okay? Guys, this is going to take practice, understanding what all these parentheses mean. But the key here is input, output. What am I plugging in? What is spitting out? What am I inputting? What's getting outputted? My inputs are domain, my outputs are range. Okay? This is going to take practice, but I need you to get these basic things down. Okay?